We're going to discuss section 1.4, which is solving equations. Some groundwork. This is just review from in the past. Remember that a variable is any letter that you use to represent an unknown number. You can use, for example, you can use an x. So like you have x plus 2. Remember, x doesn't have any value unless it's assigned a value. So if we knew that x was equal to 3, then we know that 3 plus 2 is equal to 5. You don't typically use an O because an O looks too much like a 0. So you know you can use any letter in the alphabet to represent a number. An algebraic expression is a variable, a number, or a combination of a number and variable. It does not have an equal sign. Okay, so these do not have equal signs in them. So x plus 2 is an algebraic expression. X is an algebraic expression. 2 is an algebraic expression. 4a is an algebraic expression. But then when I switch from algebraic expression to algebraic equation, that's when I use an equal sign. So 2x plus 4 equals 10. X equals 6. Those are both algebraic equations because they have equal signs in them. Now you know that you can solve something that has an equal sign in it, and we're going to get to the review of that shortly. But first, we're going to work on taking a verbal sentence, which is like how you write something, and changing it into an algebraic equation. So you have 9 is equal to, so you're writing it just like it's spoken, 9 is equal to 5 plus 4. Verbal expression, algebraic equation, although here we don't even have a variable. We move down here to where we have a variable. We have a number. Now we don't know what that number is, so we're going to assign a variable to it. So n divided by 3 is equal to 5. It could also be written like this. Okay, that's a division bar, or you can write it horizontally like that. Here a number, we'll call it x, is decreased, which is subtraction by 6. And every time you see the word is, you know that that's your equal sign. Okay, these are using properties in math. Now, we use properties kind of like you use driving laws. You don't necessarily sit there and think about what it means when you see a stop sign. You know that means that the foot needs to go on the brake and you need to stop the car. These are properties we use all the time, or laws we use all the time in math that we just naturally use and we don't think about them when we use them. Reflexive property, if you think of looking into a lake and you get a reflection of yourself back, A equals A or 5 equals 5. That seems kind of stupid, but when you get into geometry, it becomes very important. Symmetric property, for something to be symmetrical, it's the same on one side as what it is the other. So if you have A equals B, then B equals A. So I can say X equals 3 or 3 equals X. It doesn't matter which side the X is on. Transitive property, if A equals B and B equals C, then A equals C. So let's say I have X equals Y and Y equals 3, then I would know X is also equal to 3. On transitive property, you're going to have a tie between two problems. So this and this would have to be the exact same thing for you to have transitive property. So if X is equal to Y and Y is equal to 3, then I know X is equal to 3 because they're equal to the same thing. Substitution, if I have an A in a problem and I know that A is equal to B, then I could replace the A with B. So if I have 2A plus 4, I could rewrite it as 2B plus 4 and have it be the exact same thing. Addition and subtraction properties are what we use to solve for an unknown. And basically what this means is if I add b to one side, I have to add b to the other side. If I subtract b from one side, I've got to subtract b from the other side. Same thing with multiplication and division. If I multiply one side by b, the other side has to be multiplied by b. If I divide one side by b, the other side has to be divided by b. So basically these two properties are saying what you do to one side, you must do to the other side. You have to keep it equal. So what you do to one side, you must do to the other side. So here's some examples of actually using these properties. These are just solving for the unknown. You know that you have an understood multiplication there. So I have 4 times x. The opposite of multiplication is division. So I'm going to divide both sides. What I do to one side, I got to do to the other side by 4. That's going to give me 4 over 4 or 1x. So I have x left on this side and negative 3 left on that side. So I know x is equal to negative 3. On this one, I've got to do distributive property before I do anything else. Notice I could add the opposite here and take the negative 2 and multiply those. So I have 6a plus 75 plus negative 2a plus 2 equals 78. I'm going to combine those two together, so I have a 4a, and I'm going to combine those two together, and I have a 77 is equal to 78. I have to get rid of that 77 first, so I'm going to subtract 77 from both sides. On this side, that's going to give me a positive 1. On this side, those go away, so I'm left with 4a equals 1. I need to divide both sides by 4 to get rid of that 4 that's multiplied by the a. So a is equal to 1/4. Here I can rewrite this as negative 3r over 4 equals 15. I'm going to multiply both sides by 4. So I have a negative 3r is equal to 60. I'm going to divide by negative 3. And I'm going to get r is equal to negative 20. All right, now you pause the video and come back, and you try a few of these on your own, and then come back to make sure you got the answers correct. All right, I'm going to divide both sides by 9. So I have y equals 7. Here I'm going to do distributive property, so I have 5y over 6 minus 10 equals 2y plus 4. I'm going to add 10 to both sides. So I have 5y over 6 is equal to 2y plus 14. I'm going to multiply everything by 6. Now that means you're going to have to do distributive property over there. So I have 5y equals 12y plus 84. I'm going to subtract the 12y from both sides, which is going to give me a negative 7y is equal to 84. I'm going to divide by negative 7, and I'm going to get y is equal to negative 12. Here I have 2d over 3 equals 1. I'm going to multiply by 3, 2d equals 3. Divide by 2, d equals 3 over 2. The other thing you can do with this is you can rearrange problems, and you've done this before as well. This tells me I want to solve for the x. So here's the x right there that I want to get by itself. I want to get rid of this minus 3m, so I'm going to add 3m to both sides. So I get 2x is equal to 6 plus 3m. I'm going to divide by 2, and I get x is equal to 3 plus 3 over 2m. This one I want to solve for h. The h is right there. So I'm going to rewrite it as pi r squared h over 3. I'm going to multiply both sides by 3. So I have 3v is equal to pi r squared h. That is multiplied by the h. I want to get the h alone, so I want to divide by pi r squared. Those cancel out, so I get h is equal to 3v divided by pi r squared. And the homework I want you to do on this is page 31 through 32, 20 through 54 even.